Welcome back, pre-calculus. In this video, we're going to talk about horizontal and slant asymptotes. We've actually already seen an example of a horizontal asymptote. So both of our functions that we've been kind of working with periodically, f of x is 1 over x, and g of x is 1 over x squared. So the reciprocal function and the reciprocal squared function, they both have horizontal asymptotes. We've seen them this whole time, but we haven't really talked too much about them. So this is our 1 over x graph here. And we know now that we have this vertical asymptote at x is equal to 0. What you might not have also noticed is that we also have a horizontal asymptote here at y is equal to 0. And as x, you can write here that we've watched this before, we've done this before. We've written as our x approaches infinity, we've said that our output has a value here. And it's actually approaching 0 because as we bring our x coordinate out and we put in larger and larger and larger numbers, what we're doing is we're dividing 1 by a larger and larger and larger and larger number, which is getting us closer and closer and closer to an output of 0. So as x is approaching infinity, our output is approaching 0. And as x is approaching negative infinity, our output here is also approaching 0. Because we're getting closer to this horizontal line, y is equal to 0. Have a similar thing for our reciprocal squared function. We have a horizontal asymptote. Here's our reciprocal squared function. This is not to scale. This is not well done. My artistic skills leave something to be desired, but I'm trying. I'm improving, I think. And that's all you can ask, right? Just improve from day to day. That's what I'm asking from you. Hopefully it's what you're asking from me. And here we can also say, look, as x is approaching infinity, my output, f of x, is approaching 0. Same thing as x is approaching negative infinity, my output, f of x, is approaching 0. Because I have a horizontal asymptote here at the line, y is equal to 0. Just like we have our x is equal to 0 asymptote. It turns out that there are 3 cases where you have horizontal asymptotes. So here's our first case. We actually saw 2 examples of it before. So case 1, the line y equals 0 will be a horizontal asymptote if the degree of the numerator is greater, if the degree of the denominator, we were getting in trouble here. If the degree of the denominator is greater than the degree of the numerator. And of course, I will do an example for you. So let's say we have this example. F of x is equal to 4x plus 2 divided by x squared plus 4x minus 5. So we have the denominator, which is the function on the bottom of our rational function. And we have the numerator, which is the function on top. And we're looking at the degree. Remember, the degree tells us, the degree is the largest exponent we see on a variable. So in my numerator, that largest exponent is actually 1. And in the denominator, that largest exponent is actually 2. So I have my denominator, the function on the bottom, has a degree that's higher than the numerator, the function on the top. One of my students last semester called these kinds of functions bottom heavy as a way to remember. The function was bottom heavy. And that's how you know there is a horizontal asymptote at y equals 0. Of course, you know I'm going to show you on Desmos. So let's take a look. Here we go. Here's what this function looks like. Notice we have vertical asymptotes. Hopefully we know how to find them at this point. And we also have this horizontal asymptote here at y equals to 0. I want to point out something to you. My function crosses my horizontal asymptote. That's okay. Your function can, and sometimes will, cross a horizontal asymptote. What's causing the horizontal asymptote is something different than what causes the vertical asymptotes. You'll never cross a vertical asymptote, because that would mean you're dividing by 0, which we can't do. But because your horizontal asymptote is there for another reason, you can cross it. And we'll talk a little bit more in class what that reason might be. So that's one kind of asymptote you can have. That's case 1. Let's talk case 2. What if the degree, the mistake I almost made, what if the degree of your numerator is greater than the degree of your denominator? The degree of your denominator. So my student from last semester would say the numerator, he would call this top heavy because the function that's on the top has a higher degree. So let's take a look at an example of that. A function f of x is equal to 3x squared minus 2x plus 1 divided by x minus 1. So in this case, you have what's called a slant asymptote. You might have heard it called an oblique asymptote. In this case, you have a slant or oblique, they both mean the same thing, asymptote. And here's how you find it. You actually go ahead and perform this long division, which I know might have been a long time for some of you. So I'll do a little example. Oh, you can hear my baby. She's excited to see me. So you would say 3x squared minus 2x plus 1 divided by x minus 1. And so I'm going to go ahead and walk through this. A lot of students need a little review. So I know that x goes into 3x squared, 3x times. Then I multiply the entire linear factor, so I get 3x squared minus 3x. There are some parentheses around here and subtract. And then we get negative 2x, subtract negative 3x, and then we get, I started to do 5, but minus a negative is adding. So then we get positive x plus 1. Then we repeat the process. X goes into x one time, and then we get x minus 1, and we do our subtraction. 1 minus a negative 1 is the same as adding a 2. So our quotient is 3x plus 1, and our remainder is 2. It doesn't really matter what the remainder is, to be honest, What we're looking for is the quotient. This is going to tell us what our oblique asymptote is. So y equals 3x plus 1 is our slant asymptote. And let me show you, of course, what that looks like on Desmos. So here's our old example. Here is our slant asymptote. Y is equal to 3x plus 1. Isn't this a funny looking function? I like these ones. They look a little strange. But here we have this line. This is the y is equal to 3x plus 1. And our function, as x approaches infinity, y will approach the value of this line. And that's a slant asymptote. We have one last kind of horizontal asymptote that you could find in case 3. So we've looked at what if the degree on the bottom is larger than the degree on the top? What if the degree on the top is larger than the degree on the bottom? So, what if the degrees are the same? What if the degree of the numerator and the degree of the denominator are same? And the degree of the denominator are the same. So here's what will happen then. Let's take a look. So let's say we'll go with this example from your textbook. Let's say I have this function f of x is equal to 3x squared plus 2 divided by x squared plus 4x minus 5. The degree of the denominator and the numerator is both 2, so they're the same. So what we have then is we have a horizontal asymptote. Then we have a horizontal asymptote. At the ratio of leading coefficients. And you might be saying, hey, Sarah, what's my leading coefficient? Don't worry, I'll tell you. Of leading coefficients. So you remember how we found the degree 1 second ago? We said that's the largest exponent we have. We have a 2 and we have a 2. Those are the biggest ones. Your leading coefficient, I'll highlight this in blue, is the coefficient that goes along with that variable that has the highest power. So how you found the degree, that's how you're going to find your leading coefficient. Notice our coefficient here is 1. And when I say ratio of leading coefficients, don't worry, that just means we're going to have another little fraction here. So our horizontal asymptote here will be y is equal to 3 divided by 1. I'm getting this 3 because it's the leading coefficient of my numerator. And I'm getting this 1 because it is the leading coefficient of my denominator. So out here we'll have a horizontal asymptote at y is equal to 3. Of course, I'll show you the picture. Don't worry, my friends. Let's take a look. Again, notice our horizontal asymptote does get touched by our function. That's okay. That can happen. But notice as we go off towards infinity, we get closer and closer and closer to this horizontal asymptote. Isn't that lovely? So nice. So nice. So now we know how to find horizontal asymptotes. We know how to find vertical asymptotes. We know how to find the intercepts of functions. We're ready to graph. So in the next video, I'm going to put it all together and I'm going to graph one rational function start to finish, and then we'll check it on Desmos I think that's going to help with our homework. I'll see you in the next one.